Okay, are we ready for the study slam? So what's going to happen now is Adhwaith's going to talk. He's going to do 3 minutes, and then we'll have 2 minutes to answer questions. So the title made no sense to me because I'm not a very clever scientist. So the summary of his talk is converting waste to energy. Take it away.
Yep, so I'm audible. So yeah, welcome to my 3-minute thesis presentation. So regardless of what the industry is, whatever we make or do generates waste. And that is not what we need, especially in the classical economy. It's like we take, we make, and we use, and then we waste. But in the modern concept of a circular economy, what we really need to do is we take, make, and we reuse. So every product and byproduct, we need to utilize it completely so that there's nothing within the circular economy is like thrown out as a waste. Bio-waste is one of the most difficult type of waste to be handled. Last year or in the previous years, Australia has like 15.3 million tons of bio-waste, which is just thrown out mostly into landslide or other applications. But this year is a practical solution where, let's say, the primitive industries or primary industries, which is pivotal in, especially in Australia when we are in the top 5 of meat exporters and consumers. So we have like bio-waste from crops or farms and even industries. We all have it, and we kind of put it into a technique called anaerobic digester, which is basically biogas. So it's a scientific word for biogas production. And so before that, what my topic deals with is hydrothermal carbonization. So here we use a wet method under high temperature, under high pressure, where we convert the waste processes or the waste materials into something called hydrochar, which is a highly carbonized material, preferably black in color, and it has numerous applications. For example, in soil remuneration, wastewater treatment, and battery sciences, everything. And so here I use the products from any industry, organic products or waste, and treat it under high temperature and high pressure, prepare the samples called hydrochar, and use that in the other method of producing biogas. So the hypothesis is that hydrochar is kind of like a catalyst that enables more efficient biogas production. And yes, so even the residues or byproducts of these two products can be utilized within the circular economy as fertilizers and also as energy to the industries. So this project also aids in assisting the 17 Sustainable Development Goals by the United Nations members in 2015, particularly number 7, which is affordable and clean energy, and number 13, which is climate action. And thank you. I hope it was clear.
Okay, does anyone have any questions? Yeah.
Okay.
So can we actually access this? I mean, like, can we start doing this now at schools and
so anaerobic digestion or biogas production is already existing, but the efficiency is pretty low. Like, so what we need to burn or to make energy like heat and electricity is the compound known as methane. And anaerobic digestion produces methane and carbon dioxide. And carbon dioxide is not good for burning. Like, it's like a fire extinguisher. So we need a method where we can have more amounts of methane and less carbon dioxide. So that is what my project will deal with, especially the red arrow inside, which is the application of hydrochar. So I would be planning to engineer various hydrochars with different chemicals, which could act as a catalyst to produce more methane with less byproducts.
But you're able to actually capture that biomethane
Yes.
before it goes into the atmosphere.
Yes, biogas is kind of a well-known technology in most countries, used for burning gas and like cooking and other common purposes.
All right, so we've just got time for one more quick question.
So I suppose it's
Yep.
not so much a question as a feedback to this lady that builds on that. In that I live off-grid, self-sufficient. We have a biogas system
Yes.
that we use for cooking, for lights, for hot water.
Exactly.
And so I'm really interested to see how we could use the hydrochar to improve our own production.
Biogas is actually like a very old technique.
It
It's
is,
even
yes.
back in like the days when Persia was still present. So
But this is where I guess the feedback is, it actually is technology that we here in Australia don't know as much about as we should. And so
yes,
any research that
Australia has a lot of
improves that-
land, so everything goes into landfill
Yes.
instead of going to something else which could give back to the
So the
economy.
research that enhances that knowledge here in Australia of biogas and how to make that as an efficient is great. Well done.
Thank you.
All right, so as we said earlier, we're not going to go a break now. So we're just going to jump straight into Muslim.
Yep.
In circular economy,
Yes.
compared to the linear economy,
Yes.
quality of the products are important.
Yes. The main thing is like in circular economy, we try to utilize the byproducts or the waste products.
But the quality, how you assure the quality?
Like for example, in this scenario, we use the waste to make energy. So, and the quality means the amount of methane compared to carbon dioxide.
Because you have to reduce carbon dioxide levels, emissions.
Yes, and we need more of biomethane so that.
We'll discuss more.
Sure. Thank you, guys.
Thank you. Thank you.